Hi, thank you all for coming. Um, we're going to be talking about Mesopotamian archaeology here, but that's really just the example on which I'm building a series of observations on labor capacity in cities. This is a site of Tel Mozan in northeastern Syria, fourth, third, and second millennium BC. It's a city. Well, actually, it's an archaeological site, which was a city. Actually, it was several cities, one on top of each other. This is something we all know. But the question is how, apart from me saying that it's really big and really important, what are the parameters with which we can use to discuss whether this is a city or not? And what I'm proposing is to use energetics. What is energetics? Architectural energetics is a method wherein buildings are translated into cost estimates in terms of labor time units based on combining the cost of construction tasks per material derived from timed experiments on observations or building activities with a measured or reconstructed volume of those materials in the buildings. Okay, what does that mean in practical terms? How do we do that? At the site of Tel Mozan, this is a palace, the AP Palace, dating to the mid-3rd millennium BC. You can see here the plan overlaid on it. It's a large structure, a very important, a royal palace. And it's built of a combination of stone, mud brick, and plaster, and roofing beams, and so on. So this is our point of departure with the various phases that we understand here. How do we go from this to understanding the process of construction? My technique, my suggestion is threefold, a combination of three factors: a chaîne opératoire, algorithms, and a 3D model. So let's take, just as one example, one of those elements in the structure that we saw before, the mud brick production. In terms of the chaîne opératoire, we have a combination of how to go about making mud bricks. This we know to some extent from a wide variety of sources, which I'm not going to go into now, but it's experimental, textual, and based on the archaeological record. It mixes the dirt, water, and chaff, carries, fills, lets it dry, stands it up at its side so it dries better, it's ready, and then it can be transported, used, or stored. Now that we've understood the various steps in the process, we're talking only about the mud bricks. Let's move to algorithms. So how do we quantify what we just saw? This again is based on an experimental moment of experimental archaeology we did at the site, where a portion of one corner of the palace was completely destroyed, and so we've rebuilt it, following as best we can the ancient production techniques. Here you see the brick form. Here the bricks in 3 different moments of its drawing phases. And here it is for storage. So we can quantify that. Having worked hand in hand, the archaeologists with local masons, we can, because the modern architecture in the area, village architecture, is also comprised of mud bricks. And so there's the technique, even if there are some elements which are quite different, particularly brick sizes, which differ. But that we were able to make a brick form which corresponds to the ancient bricks as opposed to the modern bricks. So we can quantify this experiment that we did, saying 4 people in 12 hours, spaced over 3 days, produced 1,000 mud bricks of a certain size with a volume of 19 cubic meters. Thus, approximately 2.5 person-hours are needed to produce 1 cubic meter of brick. So now we have seen the steps. We have the numbers, and the number is sort of a generalized formula. And now we need the numbers of the volumes. So we have a 3D model. Now, I have the ugliest 3D model you've ever seen. And I say that with a certain amount of pride, because the point is not, the point of doing the 3D model, and it's I think a relatively rare case, the point of this 3D model, of making the 3D model, is not what you see here. My goal was not to make an image. My goal was these numbers. These numbers give us the volume of the archaeological record as well as a minimum of reconstruction. So bringing the wall heights up to an even height. And that gives us a total number of bricks of almost 1,000 cubic meters of mud bricks. So by putting that all together, we know that it took around 2,400 person hours to make the bricks that were needed for this palace. That's only one piece of the puzzle of understanding this palace. These are all of the algorithms that I used to quantify different aspects of the construction process. The sources of the algorithms are varied. There are ethnoarchaeological experiments, that's the one we just saw. Some are comparative experiments in other contexts or disciplines, and some are textual data from the same cultural horizon. By putting these three aspects together, we can then understand the energetic cost of a building. But we're here talking about urban settlements and not individual buildings. So how can we put this together? How can we go beyond single structures to understand urban environments? Now, labor capacity means a lot more than just the number of people, although that's obviously the key component. It requires a great deal of know-how, and so it requires organizational skills, which at its peak means the concept of writing. Because remember, we're talking about the 3rd millennium BC, so we're almost on the cusp between prehistory and history for the region. It also requires a great skill with materials. And now, that just doesn't just mean knowing how to put the pieces together, but it also means a whole structure, which, again, at its peak, ends with responsibility. So the Codex of Hammurabi, a large section of the Codex of Hammurabi, is dedicated to punishing builders whose houses collapse. So if a man whose house collapses and kills his child, then the builder will be fined, and so on. And there's a whole section in the Codex dealing with responsibility. And finally, it requires a great number of tools that are available because, for example, transporting 1,000 cubic meters of mud brick is quite a task. And so whether one is carrying them by hand, by sled, by wheeled wagon, makes an enormous amount of difference in terms of the labor costs. Labor capacity also leads us to the question of specialization, which feeds nicely into the paper we just heard. Being able to build something in stone as this palace means also the ability to quarry large numbers of blocks. It means the ability to float those stones on waterways to be able to transport them. And so when we're considering labor capacity, it means that we're also looking at questions of specialization. And specialization means not only the ability to do those individual things, but it also means the ability of the society to support people who do just that. So it means that if your main task is going out and worrying about your fields, then and everybody has to do that, then of course specialization becomes much more difficult and the bell curve of specialization gets much flatter. And finally, the understanding labor capacity and the buildings within a settlement can also help discuss the question of surplus and elites within a settlement. And of course, this is one of the main markers for the difference between a settlement and a city. So let's follow that, the question of the elites and surplus, looking at the growth of cities. And this is a quote from Trigger. At the most elementary and general level, political power is universally perceived as the ability to control energy. No ruler can retain political power if he does not invest much of this energy in activities that help to maintain and, if possible, expand the society he controls. Yet the most compelling demonstration of power is the ability of a ruler to consume some of the energy he controls for non-utilitarian purposes. So make big, beautiful, useless things. And that leads us to some extent to different aspects of what we can measure with energetics. So things such as infrastructure, but also the monumental buildings. So the palace that I saw is a non-utilitarian structure in that there's the adage that the king makes a palace, but it's also a palace that makes a king. And so this relationship between power and energy is very, very important to understanding cities. And we can use energetics to understand on two different levels: a synchronic, so looking at monumentality, the materials, the complexity, and the size of buildings. There's a very nice study that was done by Sebastian Hagenower and Felix Levinson on Uruk structure, showing that one of the structures there is considerably smaller than the rest, but uses a material which was so much more valuable that it's the most costly building in all of Uruk. This is, again, 4th millennium BC. So, so these are the kinds of approaches that can help us talk about what lies behind monumental buildings and cities. And then, of course, there's also the energetic distance between what is monumental and what is private. So that helps talk about, for example, especially the elites. So how much more costly is a palace as opposed to a private house? In relatively egalitarian societies, it wouldn't be a palace, but sort of communal structures are much, much closer in terms of cost, energetic cost, to a private house than they are in highly stratified societies, where a palace, such as the one that I showed you, is much, much, much more expensive than a private house. Interestingly, it's the palace, as much as it costs, is considerably cheaper than any of the infrastructure projects that were undertaken. So I also looked at the difference between a palace and a city wall, and the city wall, for a much smaller settlement, is exponentially more costly than making a palace. So that really brings us back to Trigger's quote. It's really that last slice of the pie, that little bit of surplus which the ruler can employ in non-utilitarian things, which help us talk about political power and urbanization. And of course, that was the synchronic, but also on the diachronic level, we can use this analysis, considering how monumental structures are added to a settlement or how they're changed over time. In another session, they were talking about how churches were built one on top of another over a period of time. And yes, that's done, but it's not always the same building. And we know this from textual material from the ancient Near East. Each king builds the temple, which just means that they rebuilt the temple or modified it. And they always make it a little bit better. And what is that little bit better, and how can we quantify that little bit better, and what does that reflect about the society that's there? And we can look at the difference between this over time, the difference between the investment in infrastructure versus non-utilitarian structures. Then, so in the beginning, I talked about the chaîne opératoire, the algorithms, and the 3D model. Now, the chaîne opératoire is something that other people have worked on, and it's also quite structure specific. The 3D model is, of course, unique to each building. The algorithms are not. The algorithms are something which can be, because of their general nature and because it's a tool for measurement, are inherently, as much, and that's a point of discussion maybe we can have afterwards, but are inherently general and can be applied to a wide variety of structures. And so I put together EnCAB, the Energetic Calculator for Ancient Buildings, which is an online tool, a library of algorithms where people can plug in their own data. So EnCAB, the Energetic Calculator for Ancient Buildings, provides a library of interactive algorithms. And it also provides research paths combining clusters of algorithms, which basically parallel the chain operatoire, discusses terminology use, gives bibliography, critique for sources. It's open source, so it allows for changes to the input as well as the program. And it cites the works that use EnCAB, of which now there's only one or two, providing really a locus for collaboration, because these the use of these algorithms are a powerful tool because of their ability to compare across within one urban settlement, but also across space and time. Here's just one example showing up, talking about how many mud bricks can be made per day with a various set of hyperlinks and whatnot you can imagine. Based on material, they're sorted by material, source type, and geography and whatnot. This means that research using these algorithms are reproducible, both on the tool side, where the algorithms and assumptions used to estimate the energetic costs are explicit, as well as on the data side, where when in the published algorithms, there is, it's quite clear what the source comes from and the original bibliographical reference. EnCAB, these algorithms, are merely a tool because it's a tool for measuring. So it's not a solution in and of itself to any problem, which is a good thing because it means that it can be really used in a wide variety of contexts. It provides a bottom-up approach which links archaeological data and theoretical discussions, which I think is a really very powerful and very important digital tool, which means that we can tie discussions of prestige, monumentality to the single bricks which make up the edifices. And I've just added that EnCAB is also a locus for discussion, in that research using EnCAB are listed giving basic information. So another paper talks about knowledge foraging. And in this sense, EnCAB can be sort of an aggregator for these kinds of questions and the algorithms themselves. Almost. In the check object integrity, the discussion of what we were going to talk about this year, the questions came up. Can we answer the question of whether our exploits will pass the test of time? Are we able to propose comprehensive and functional solutions for archaeology? And I'd like to add, can our current exploits breathe new life into the work of others, of older documentation? Is our work flexible enough to adapt to changing situations? Is it accessible enough that others can use it as a building block, even if technology radically changes? And I hope that EnCAB responds to some of these questions. Thank you, and here's the website.